Thank you, Bryce, and thank you, everyone, for the honor of being here. I just have to say that this is a tremendous, a really special honor, because I think this is a really special moment in the evolution of this dialogue that His Holiness had the wisdom to suggest back in the 1980s to come together between contemplatives and scientists and discuss questions that were at really the most basic levels of appreciating who we are, what our mind is, and how we relate to the rest of the universe. And for 25 years, there has been a very active dialogue, which has been institutionalized in the Mind and Life conferences that have involved His Holiness and various scientists over the years, but relatively few other monastics. And this is an amazing thing that we're now, through these educational programs of Science for Monks and the Emory Library collaboration, being able to really expand this dialogue to so many people in the Buddhist tradition, which is a tremendous thing. So many monks and venerable monks and nuns being here. So this is a very, very special moment. I don't know how much new I'm going to be saying in the next 30 minutes or so, because many really powerful ideas have been put forth already in the day and a half that we've been talking. More will come. And what I will say, though, will be my way of saying it. So sometimes different ways of hearing the same thing are very valuable in appreciating the complexity of these problems. So this is the Andromeda Galaxy again, this famous galaxy, which is our nearest neighbor in the heavens. About sometime back in the 1970s, there was a short 10-minute or so documentary movie made that was called Powers of 10. And Powers of 10 tried to illustrate in a movie form, actually did a very good job of illustrating in a movie form the scale that Paul was just talking about, from the very largest things in the size of the universe, for example, all the way down to subatomic particles, 10 to 42 orders of magnitude or so. I'm not going to show that movie, but a few years ago, there's a very famous American television cartoon called The Simpsons. Some of you may know. And it's in America, I believe it's the longest running show that's ever been on television. It's very clever. And a few years ago it's still on. A few years ago they had a opening scene that was a variation on this Powers of 10. And I think it illustrates a very interesting thing about the theme of our conference, Cosmology and Consciousness. So I'm just going to take 30 seconds to share that with you now. Ooh. So, as some say in America, this is considered a comedy. However, this is saying some really profound things, I think. You asked a few minutes ago about the connection between cosmology and consciousness and what can we say about it. We can certainly say what you said, that everything that we know about anything at all, we believe is coming through our consciousness. It's coming through our awareness, and any theories we have about the physics of the universe have been created by our brains, minds. So there's that connection between cosmology and consciousness. In fact, it was something like that connection that first got me interested in this whole subject, because when I was an undergraduate student, I was studying physics and general relativity, and I began to wonder how it was that Einstein could sit in his room and invent a theory that describes the whole universe. I mean, how is it possible for humans to do that? So that's definitely a connection between cosmology and consciousness. I think another connection which we don't know about yet, and which is somewhat embodied or illustrated in this movie, is that there's some profound connections between our inner reality of our mind and the outer reality of what we call physical reality, including the large-scale nature of the universe, that are still very much beyond our limits of knowing how these things are connected. And that I believe that perhaps the next big revolution in science will, in fact, somehow shed some light on that. I think that would be very exciting if that were the case, and there's no reason that it may not be the case, and what we're doing here really speaks to that possibility. So the word science actually comes from knowing, to know, and so science is a way of asking questions about our world of experience and designing ways to test, gather data, do experiments, and then form theories to try to explain organizations of things. It's a way of gathering information and organizing it and expanding our framework of understanding by doing that. So it's a very, very general term. It applies to understanding our outer world, and there's every reason that it could also apply to understanding our inner world, asking questions, gathering data, developing theories, and so forth. Western science, what we call Western science, which is developed out of the tradition of Europe and America, really has now spread to the entire world. It's the way, kind of the framework in which science is conceptualized over the entire world, is grounded in astronomy. It began with trying to understand the movement of the planets and the movement of the moon and the sun and the earth, and these guys here are the sort of acknowledged founders of Western science: Copernicus, Galileo, Descartes, Newton. Descartes was actually one of the first people to sort of suggest that it works well to try to understand our outer world, that our inner world is maybe more complicated. And Newton took this to the next step. He explicitly said, I can't deal with experience. I don't know how to account for the redness of red. What I can talk about is the mathematical properties of light. And he invented an entire mathematics and and physics around it to do that. And Newton also was very good at making connections between the movements of the planets and the sun and moon and what was happening here on Earth, like an apple falling, and showing that there were universal regularities and laws that could describe these things. And so this has become an extremely successful framework and has been expanded by people like Maxwell there down at the bottom, and Einstein into the 20th century, and provided by the beginning of the 20th century, an awesomely successful framework for describing our physical world. And in the 19th century, this began to be applied to biological things too. Darwin was really the main mover of a revolutionary new way of looking at living organisms. And as our technologies of observation got better and better in the 20th century, so that we could examine cells and later molecules and so forth, we were able to describe the cellular and molecular chemical makeup of living organisms in a really detailed way that was completely continuous with the way physics and astronomy describe the larger scale structure of the universe. And so we now have, if we bring this to the present day, we now have an awesomely and beautiful and stunningly powerful framework of understanding, which we call physical science or biophysical science, if we wish, that describes everything from the furthest reaches of the observable universe all the way down to the microscopic layers and the makeup of cells, the makeup of organisms, the structure of DNA, the structure and functioning of the brain. This is all beautifully articulated in this framework that we can call Western physical science. And again, we call this Western physical science, but everybody does it. And it has led to all of the wonderful things that we like to play with, like computers like this and mobile phones. If you have a mobile phone, you are a beneficiary of this way of looking at the universe. So it really works. And just to introduce a few more terms, I don't want to get too caught up in this, but beautifully translated by Karma here, these ideas of physicalism or physical materialism is another way. It's a word that can be used to describe the framework. I keep using this term framework. Science, I said, is just looking for knowledge, gathering data, doing experiments. However, we interpret all of that right now in a particular framework which can be called physicalism or physical materialism. It's that everything is made of matter, basically, or more technically stated, that everything is describable in terms of mathematical quantities attached to coordinates in space-time, as a technical definition. So masses, energies, field strengths, locations, space-time coordinates, and so forth. That's the way everything is described, including what's going on in the brain. I mean, we don't usually talk about it in exactly that language, but if you really trace it, you could. And that has given rise to a kind of hierarchy or connection between different fields of science, with physics often considered the most fundamental, describing things at the very microscopic levels of interaction. And then atoms are described by chemistry, and the behavior of atoms can be described by physics, but when you get larger number of atoms coming together to form molecules, then a new kind of area of scientific description emerges that we call chemistry. And then if some of these atoms come together, molecules come together into particular stable configurations and form entities that can maintain their stability over time by consuming energy and replicate themselves. We call that life, and that's studied by biology. And if we look at a particular piece of biology which is related to how the body and brain are working to produce behavior and analyze sensory information, we call that area neuroscience. What's missing from this is mentality or mental experience or mind or consciousness or whatever we wish to call it, that experiential piece. Now, another thing that I don't want to spend a lot of time on right now, and is an important subject that it would be nice to put together a nice coherent piece on sometime, would be the different ways that those words are used, because in Western science there's really very limited history of being interested in describing mind, consciousness, mental experience, and so forth. In fact, it's been almost explicitly excluded, beginning with Descartes and Newton, and continuing to into the 20th century. The focus was always on the external world and what could be described by mathematical relations. So in Western scientific language is impoverished in the way that those terms are used compared to, say, Buddhist philosophy, which has a much more elaborated and nuanced appreciation of those terms. So I'll use them kind of loosely, and hopefully you'll forgive me for that right now, and we can come back and repair those things later. So there's no place in this particular hierarchy for mind as it's conceived right now, which leads to what has been called in Western science the mind-body problem. That is, okay, we've got this mind thing, this mental experience thing, this consciousness thing, whatever we call it. How is it related to processes that we can measure by our technologies and scientific analysis that are happening in our brain and our body? And I'm not being exclusive to the brain here. We know the brain is very important for the mind, because if you produce damage to the brain, you get really powerful and specific damage to mental function. But there's a lot of stuff going on in the body that's also related to our mental experience. So how are they connected is the question. And if you ask this question to most neuroscientists, if they'll probably give an answer something like this as the solution, and most philosophers too, that we must have to somehow identify these subjective internal mental processes with their objective, describable, physically describable neural correlates. By neural correlate, I mean, what can we measure that's happening in the brain when this mental experience is also happening? If we're feeling happy, what kind of brain activity is related to that, and body activity? If we're feeling sad, what kind of brain activity or body activity is related to that? And then many folks, even though they don't know how at this point, will simply somehow identify that with the mental experience. And nobody knows, I say simply and obviously, but it's completely mysterious how this happens. And nobody can answer that. They simply believe that because this framework of scientific explanation has been so successful for so many centuries now, that it will have to eventually be successful for this too. We just need to study the brain more, build better fMRI machines, do more experiments with more different kinds of people, and it eventually will emerge somehow from body and brain physiology how these things are connected. And maybe that will happen. That is certainly one possibility, even though nobody exactly knows how. Now, 100 years ago or so, one of the great pioneers in American experimental psychology was this fellow, William James. And he was very interested in the study of the mind and how the mind is connected to the body and the brain. And he actually proposed back more than 100 years ago that one way for the science of mind to move forward would be to develop a rigorously empirical, introspective way of making observations and doing experiments, somewhat like the contemplative traditions have a long history of doing. But James seemed to not have a lot of knowledge about those traditions at that point. He tried to get things like this going in American experimental psychology, and it went absolutely nowhere. In fact, it got kind of completely bulldozed by the movement that Bruce Grayson mentioned this morning of behaviorism, where rather than study the mind on its own terms of subjective internal experience, just study the brain and the body. We're better at doing that. But James also said something else, which was very, very profound. In a piece that he wrote back in 1895, he also pointed out that all of these ways of observing matter are based on the physical science of the time, and that the assumptions of those natural sciences are provisional and revisable. And he said this in 1895, and it was remarkable because many physicists in 1895 thought that physics was a closed book and that everything interesting had been discovered, and it would just be a matter of measuring things with more precision. That would be the future of physics, and no group of people were ever more wrong than the folks who said that, because just a few years later, beginning in 1900 with Max Planck and then following up with Einstein in 1905, the seeds of what was to become the quantum theory. They didn't have the quantum theory, they had just had the notion of quanta of energy, but it led to an enormous revolution in physics, a true revolution. By revolution, I mean before and after these events, people viewed the world in very different ways. And when it came to viewing the world of physics, it was very different before and after the quantum theory, which was developed in the 1920s, beginning with these guys, Heisenberg, Schrödinger, and Bohr. And what the quantum theory does is it rose out of a necessity of describing experimental facts that were gathered in the study of atoms that were completely inexplicable in terms of the physics that had been developed by Newton, Maxwell, Einstein up to the 20th century and so forth. It is, as Paul just mentioned, it is really very much illustrated in this double slit experiment, which I won't dwell on, but just to point out, this actually does show pictures of single photons of light hitting a photographic film, and so you can pick out, the dots one at a time, and it shows as over time they build up, illustrating an interference pattern, which demonstrates that these single particles of light have somehow gone through both slits and interfered with themselves. Now, I'm not going to dwell on that except to say that this was the first hint that the way in which questions are asked in fundamental physics is now appreciated to have an impact on defining the result of the experiment. But it goes beyond that. What the more recent experiments have demonstrated is that there's a way in which the very essence of physical reality is not definable until the question is asked, which is a very profound statement. Now, I don't even have a deep enough understanding of that, and I've been struggling with this for years now. So if you don't fully understand what I say when I say that, don't worry about it. But believe me, when the bottom line with quantum mechanics is that there's a very, very strong suggestion that there's something about the interaction with what we call the external physical world, that is very much intertwined in some way with our own mentality, our own decisions, our own consciousness, our own perception, something like that. And nobody has a clear answer to this. You know, many very brilliant physicists have thought, beginning with the founders, thought about this, and continuing to this day with many very prominent physicists thinking about this. And everyone agrees that this is a problem, and no one has a good answer to it. But so the seeds are there of some very interesting stuff, connecting mind and brain in some way. So as was mentioned earlier, I think you, Bruce, you mentioned how this was appreciated by people like Bohr, Heisenberg, and Schrödinger, and they also appreciated that they weren't psychologists, they weren't biologists, they weren't neuroscientists. They didn't really know how to deal with consciousness, so they didn't really go there. They simply said, "There's weird stuff happening here," and the equations still work, and they allow us to make predictions, and you know, maybe someday somebody will do something with this, and maybe this is the day. So in summary, there are a number of pieces of data and things around that support some kind of expanded framework of explanatory framework needed to describe these things that relate to our minds or our consciousness. You know, one is the simple inability so far to really get some kind of experiential or conscious awareness out of brain physiology, out of the movement of atoms and molecules and so forth inside our brain. Very powerful data that was described by Bruce Grayson this morning from near-death experiences and reincarnation studies. And of course, you have many more examples of reincarnation stories that are not explained by simply saying that whatever consciousness is a product of our brain and body working in some way. I mean, certainly our bodies and brains are very much a piece of the picture while we're alive, and somehow there is more going on. It may not be that there's a simple way that's graspable by us yet or ever to explain reincarnation, but there may be, you know, very interesting and weird things going on in the movement of, you know, kind of characteristics of our consciousness across lifetimes in some way. There are also things that we haven't talked much about, but for which there's an enormous amount of scientific evidence, data collected over more than 100 years of careful experimentation, demonstrating things like telepathic communication between people, precognition, that is having some sense of things that are going to happen that haven't happened yet. And again, these are very common in, say, the Buddhist tradition, where people have precognitive dreams that will indicate that something is going to happen to look out for. In the traditions of India, the ancient traditions of India, including Buddhism, you know, people talk about siddhis or other special powers that can come from long periods of practice, which would include things like precognitive and telepathic abilities. So there is a lot of data, but none of it, you know, is taken seriously by Western science because there's no way it can be explained in the framework that we have right now. And so, just in conclusion, I'll also say that if you talk to the people who are really working at the frontiers of physics right now, folks that are involved in particle physics, this Large Hadron Collider in Switzerland-France border where they're banging particles together at very high energy and trying to create new things. You know, some of them are very confident that any day now they'll discover the Higgs boson, and that'll be the final proof that the Standard Model, which is a nice package of way of describing elementary particles that has been developed over the last 30 years will be complete in some way. And others will say, you know, I mean, I have a standing bet with some of my physics colleagues, they won't find the Higgs boson in the next 3 years in the Large Hadron Collider. You know, it's just, and that might be the most interesting thing. If they don't find it, that means that there's something really kind of missing in the way that we're conceptualizing microscopic matter. So there's very interesting stuff that at the frontiers of physics way down there that may not be easily explicable. And if we go the other direction, you know, there have been several allusions already to dark matter and dark energy, which composes something like 95% of what we believe the energetic content of the universe is. And it could be that there will be some completely new way of looking at the large-scale structure of the universe that will come about before we understand these things. And so, again, I was talking to one of my colleagues a couple of weeks, well, the day before I left for India. He's involved in an experiment to detect dark matter in some mine deep in South Dakota. And he said, you know, I don't think we're going to find anything. I think what will really contribute is that we will very carefully demonstrate to the limits of experimental precision that we can't detect it. And that means that there's something really missing in the way that we're going to need to kind of look at the structure of the universe, which is very exciting. You know, I actually believe that we are poised for a revolution in the mind sciences. You know, the science of mind in Western science has not had any revolutions like biology did with Darwin or physics did with quantum mechanics and relativity and Copernicus and Newton. And mind science is really poised. And wouldn't it be interesting if whatever the revolution is in mind science somehow also embraced things in cosmology, and there was greater insight there. I mean, that's a long shot. It's a wild one, but you know, wilder things could happen. And so that's really what makes this dialogue super interesting, because the revolution is poised to happen, perhaps, and part of that would be a more deeply analytic examination of the mind, which many of you are expert at, and also the capacity to really think out of the box, to think in new ways about how to explain phenomena that may not be explicable easily from either of our perspectives, that may need some, you know, new synthesis, some completely new way of looking at things. And wouldn't it be cool if it happened while we were around in this lifetime to see what it is? So thank you for your attention, and to be continued.
Okay, thanks very much, David. And 5 minutes, say, before the break, but if Geshe want to have a few questions.
아니 이 지무 지르던지 아니 저 동동지 쉬어요. 아니 누주 지리비게 로와신진당 다가나지긴 페이지 제당라 산나당와이나 아니 잔소구나니 차선당 델리게를 비긴 페이지 존행기 냐다 다가나지긴 짜던 주 시니긴 로미 차진 노요를 나론수 남비기 시줄라 따와이나 델리 도데 가르숭으로서나 남비기 enzu 존전 추지 좀이게 나라 아니 신우지디 미네 야차 누지신지 예네 마트로스 두지닝기 동시데니라 따온데 삼발라 아니 신우지데데 토마차온데 삼발라 룽기 롱차모 난가 동비게 롱레 롱차모지네 르메게 메단 칠라서 아니 사 두지네 조아데 남지기 시데요레 다가너지기 동시 심마들 따와이나 로아신지 중데 삼발라 아니 예레 마트로스데 삼발라 아니 오세질 할리기 조아지 시데요레 대마세바 하바드 다디기 까바디 체바드 시비긴 로아 미데 성디니발리기 조아지 도디오르와 든지도 아니 쿵주기 든지기 jansugi chasin la zuligi ani sinjigi chubada daganajin ki jejol in chubaji dodi dos tindi indu ngige dadigi zambili ndi tola yodi jugo sudi nanji ki jinjigi thoma de ani ji zambili rang tini chuaji rewa ani zaka jimbal tini chuaji ris an chuba thunuji shuai tujena.
My question is that it's related with biology, and so this is for David. And in biology, when we talk about the evolution of living beings, we talk about the life begins in ocean from a single-cell organism to a multicellular organisms, and then to primates, and finally human beings. In Buddhist traditions, however, have a different, a completely opposite kind of view. When we started in Buddhist tradition, it says that when the universe, when the life started, it has got the more power mentally and physically, and then it gradually reduced with time. And when we talk about the world that we live in, physical world that we live in, it talk about the generation of wind element first, and then the coming into being of earth element, and then the fire, and gradually there is also a process of how this physical world is coming into being. And so my question really is that when we talk about the life on this earth and the physical substance, or the unique physical substance that is embodied in our body, or embodied in living beings, can we say that it is come from a different planet, or the extra terrestrial area, or is it so? Is it just come from the earth itself? I think he's talking about the origin of that first cell, how that first cell on this planet came into being.
Well, that's an excellent question, and the excellence of that question really is highlighted by the answer is not known in Western science. Many brilliant scientists have worked on that and are continuing to work on it, the origin of life. And we do not have a story to explain that, other than the conventional one is that, well, with lots of time and lots of banging around, something will happen. It's one of the reasons the astrobiological research is so interesting, because if you try to look for life in other places, and it looks the same or it looks different, that really has value in addressing this question. Some scientists of prominence, including people like Francis Crick, who first discovered the structure of DNA, co-discoverer of the structure of DNA, have suggested that life on Earth actually did come from other places in the universe and maybe landed as some kind of spore or something billions of years ago and then evolved here. So it's a wonderful question for which we don't know the answer, and you might have more to say, given that
Yeah, I'll make a few comments. So the idea of life that travels between worlds is called panspermia, and it's a 150-year-old idea in science. And so astrophysicists, planetary scientists have investigated it, taken it seriously. And the answer at the moment seems to be that transport of potentially living organisms inside rocks is quite possible within the solar system. And in fact, the conveyor belt, the sort of inefficient transport system in the solar system, works quite well from Mars to the Earth, because Mars has weaker gravity, less atmosphere, Earth is closer to the sun, less efficiently going the other way. And provocatively, since we know that Mars was almost certainly habitable 3 or 4 billion years ago, it is distinctly possible, quite possible, very hard to prove, that life on Earth came from Mars. So there's possibilities of moving life within a solar system. The question of can life travel between stars has also been investigated a lot in the last decade. And it turns out to travel on a rock, there are two issues. There's one, can the rock be ejected from the system? And second, does the rock take so long to travel that a microbe could survive? The answer to the second question is that microbes have been resuscitated after being dormant for 15 million years, and that's about the time it would take to travel between near star systems. So in principle, a dormant microbe could survive the journey. But the probability of a rock being ejected from a planet and landing on a moon or a planet of another star system turns out to be infinitesimally small. So astronomical calculations suggest that life transport between star systems is very, very unlikely. And of course, if life originated elsewhere, you've essentially just shoved the problem, somewhere else. You haven't explained the origin, you've just put it off into another place. You still have a problem, you still have a thing to explain. So that's what the astronomers have figured out.